welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. Hi everyone, my name is Alice. I am a host at House of ZK Radio. I'm joined here with Conner, who is lead researcher at Prooflab. Very excited to have you here today, Conner, to talk about your work with stress testing, with security research. So thank you for being here.
Yeah, thanks for having me.
Yeah, thank you. I wanted to first speak to you a bit about your background. So I know you've had quite a lot of experience in crypto and in just regular software development as well. You've been in crypto, working in crypto for, I believe, 8 years.
Yeah.
Yeah. Then you were working at Cello. You even helped with their Plumo trusted setup, and then even with Mina as well. And then, to my knowledge, you then pivoted to AI for a bit, and then now you've come back to work in ZK and specifically with security research there. So I'm very curious to hear about first, like the motivation for coming back to work into ZK and how that journey looked like for you.
Yeah, I mean, to say it's a journey is kind of an understatement a little bit. I think that people that exist in crypto only, are kind of here for like 2 or 3 cycles. It's been like at least 4 at this point. I don't know. I was mining Bitcoin when I was a kid in high school, and I had my mine 100 Bitcoin and then lose it all because your parents clean out your room when you go to college kind of situation. Yeah. And I kind of got interested in crypto around 2017, 2018. Ended up kind of working at Mina a little bit, built some foundational testnet infrastructure, moved on to Cello, worked on a whole bunch of different projects at Cello and some kind of, entry-level crypto Twitter personalities. So the Cello project turned into Nomad, which is a whole saga. I don't know, I feel like a lot of people got out of crypto around that 2022 period. Like 2020, 2021 was like a really exciting time for crypto that kind of like reached a frantic fever pitch and then kind of exploded in a spectacular fashion. And AI is like really cool, it's foundational. Tried my hand at B2B SaaS and learned that sales is pretty hard, got back into crypto again, which I think is a pretty typical story these days.
I see, nice.
Yeah.
But it's very cool that you were able to first work there starting back in 2016, 2017, mm-hmm. Work there for a few years, and then go into B2B SaaS for a bit, and then come back. So I think you have a pretty good amount of diverse experiences there.
In terms of motivation though, I think it was Jeremy from Risk Zero speak at ETH Denver in 2022. Just talking about zero knowledge virtual machines, and the idea, my experience at Mina was ZK is really hard, really kind of impossible stuff. You need a PhD in cryptography to really understand, and I worked with some people that had PhDs in cryptography, and just had a really hard time explaining it to me, somebody with more of a DevOps infrastructure SRE background, and just kind of hearing Jeremy speak. It was kind of this light bulb moment of that's an architecture that I can understand of you just write software, you stick it in the machine does its thing, get a proof, and move on with your life. And I don't know, that was kind of 2 years apart between the time that I started thinking about ZK and ZK VMs again and the time where I actually landed at Succinct for a period of time. And got to work with teams that were building stuff around the time of the Succinct residency. It was a really cool experience kind of being in the office with everybody and just learning about ZK VMs.
Yeah, absolutely. And it's great nowadays you even mentioned about that improvement in the developer experience as well. Mm-hmm. ZK is hard and not many people know how to handle those circuits.
Yeah.
But now with these ZK VMs like Risk Zero, like Succinct, mm-hmm. Now just regular developers can just write programs in languages they're familiar with and then have the prover itself do all that hard work, compiling and improving, and then just get a proof that's generated out of it. So I think we've come a very long way, and I think the way that you framed it before was ZK VMs as kind of the next PyTorch. We now have this new kind of framework, these new toolings that we're able to use, and now we have this new abstraction layer. So the experience there with using ZK is not as difficult as it was before.
Yeah, that's a really good point that you bring up of just like, I did some writing kind of right around the beginning of the year, January, February, and I really see this kind of inflection point in crypto technology around exactly like you were saying, the different layers of abstraction. And the thing that really made AI take off, AI was a slow burn, 10, 15, maybe 20 even years. Started out as like a DARPA research sort of thing, which is exactly where ZK and FHE, MBC, all these things started at DARPA really. And it took this like really long time to sort of get to the point where, okay, now we have these abstractions that normal engineers can pick up and use. And I think that, the next 18 months is going to be explosive growth period for ZK.
Yeah, absolutely. And it's really interesting you draw those parallels with AI as well, because now that I'm thinking of it, we can compare, say, LLMs to ZKVMs almost as kind of the underlying infrastructure. And we see so many AI-based projects that are, say, using wrappers or building on top applications on top of these LLMs. And hopefully we can see a similar movement in terms of new ZK applications that can be built on ZKVMs and other kinds of infra as well.
Yeah, and like you can really take this analogy and you can like beat it to death. Like you've got MBC, which is like the interoperability solution for LLM applications. Like we don't have that yet in ZKVMs, but I think that we probably will sometime in the next 24 months.
Yeah. In the next 2 years, we can expect quite a lot.
Yeah.
So very, very exciting time. I wanted to also speak to you a bit more about your work with stress testing, security research, which is what Prooflab is about. And you are wearing your Prover Killer hat, which I'm very excited. So we can talk a little bit more about Prover Killer specifically in ZKarnage. So I was wondering first about the motivation behind that, behind the need for stress testing, especially right now with these ZK provers and ZKVMs.
Yeah.
So going into the initiative for ZKarnage, but then also about the motivation of Prooflab itself.
Sure.
Curious to hear why you see stress testing and doing this kind of security research with ZK provers as a need right now.
Yeah. So like I mentioned a little bit ago, I come at applied cryptography from a different kind of direction than a lot of people do, I think, which is I'm a site reliability engineer. And generally, for those of you that may not be aware, the way SRE works is it's usually a team of teams. You get attached to a software engineering team that isn't necessarily meeting their KPIs, their metrics, whatever. You come in, you learn what they do, you diagnose, you collect data, and then you suggest improvements. And that's what I really started to do. I built some stuff with ZKVMs. I found it kind of difficult. I found it slow. I found it annoying. And the only way for me to figure out how to improve it is to collect data. So that's really the genesis of what Prooflab started as, was a benchmarking initiative. And we very quickly came into the understanding and realization that trying to boil the ocean by benchmarking every single ZKVM is a kind of an impossible prospect for an individual researcher. But what I can do is I can look at Ethereum. I can look at the Ethereum virtual machine, which is very simple, compared to maybe RISC-V or MIPS or the different sort of architectures that exist. And through that lens, it turns out, and this is kind of my hot take, my opinion, a lot of the ZKVM development is in furtherance of proving Ethereum layer 1. So if that is true, the increasing sort of amount total secured on Ethereum layer 1 and then kind of all of the rollups, there's a lot of money and value at stake. So I kind of if you know anything about Nomad, my past sort of experience there has informed maybe let's not lose all the money. And as a result, that's ZKarnage. Let's cause a little mayhem. Let's do it in a safe, controlled way, and let's collect some data for kind of the future generations of people that are going to build on top. Yeah,
absolutely. And it's great to hear that you kind of applied your frameworks of thinking while you were working as an SRE. So trying to diagnose any diagnosis system, see any potential bottlenecks, any potential vulnerabilities, and then try to build more resiliency for that system as the next step. So I really like that approach, and I think that this is absolutely very needed for all the ZKVMs, ZK-provers who want to go into the ETHProofs initiative, or any sort of kind of real life production use case. Definitely very important to diagnose any potential vulnerabilities earlier on.
Yeah. So let's talk about like what is ETHProofs and like what is ZKarnage specifically. Basically, the Ethereum Foundation and their continuing infinite wisdom has put together this really cool project called ETHProofs, which is you could call it an industry initiative where the different ZKVM teams that are the different ZK EVM teams that are building cool stuff can submit proofs of Ethereum block transitions. And that's a really useful primitive to have in terms of like the data for that, because it shows growth, it shows performance improvement, and it also allows teams that are building, for example, ZK Layer 2s and integrating different ZKVMs to have and make informed decisions. Which, if you're really thinking about it, like this time last year, it was really hard, if not impossible, to really make an informed decision. It was just like, you're just kind of like closing your eyes, picking a name out of the hat, and then that goes straight to production. So that's what ETHProofs is, and ZKarnage is basically a project that we have grant funding from the Ethereum Foundation to submit malicious worst-case blocks on Ethereum mainnet with the explicit intention of sort of surfacing these results on ETHProofs.org, which is the dashboard.
Mm-hmm. And another thing I really appreciate is that you guys showcase all your findings to the public, and you're making it like an open source kind of data set for different teams to see, and for any teams that want to build on top of these ZKVMs, these ZK-provers. As you said, it's very important for them to be able to make an informed decision, not like closing their eyes, picking a name out of the hat. So that's a really great way, I think, to reach some sort of industry standard, and then allow these teams who want to build on top of these ZKVMs to see all the considerations, and depending on the use case they want to make, from there they can choose which ZKVM they want to build on top of. So really great points that you mentioned there. And I also wanted to go a bit into some of the details regarding some of the, say, discrepancies that you found between, for example, some kind of operations gas costs with the actual reality of the ZK system. So the amount of resources it uses, for example. I know for ZKarnage specifically, they're looking at those discrepancies, say, for example, some specific opcodes that are being used, EVM specific opcodes that aren't exactly ZK friendly. So that may lead to some discrepancies there. But wanted to ask you a bit about some of those specific discrepancies that lie between gas costs versus, say, like the cycle count that you would see with ZKVMs. Yeah.
So like really the first question to answer is like, what is the EVM, and like what is a VM? Like what is a computer? Computer takes a set of program instructions, it runs them more or less sequentially from top to bottom, gets the hardware to do stuff. The EVM is a special sort of computer virtual machine that takes program instructions. These program instructions cost gas. Gas is effectively money at the end of the day. The more complex your program, the more instructions, the more gas you pay, the more money, the more expensive. The purpose of this research is the interesting sort of connection point between the EVM and the ZKVM. ZKVM is also a computer; it just runs, instructions in sequence. But the difference is you're paying with time. So you've got one machine that you're paying with time, the proving time, the time to execute the program. One machine you're paying with money, and when you kind of smush these two things together, now you've got this interesting situation where I can potentially spend a little amount of money and make the prover take a lot of time. And that's actually bad for the system, especially if, for example, you need to generate a proof of the previous block before you can generate the next block. Maybe I can craft a transaction in such a way that prevents the system from creating a new block. And that's what we call a liveness vulnerability. Ethereum, I think, turned 10 yesterday, the day before. Ethereum's never had downtime. if this were to, if we were to just shove a, ZKVM or a DAEVM directly into Ethereum layer 1 today, that might not actually be the case. So it's really important to sort of make principled decisions when you're integrating these two really complex systems, and that's kind of the through line in terms of the specific project, how it relates, how these two things plug together, and why this is all important.
Yeah, absolutely. And just on top of that, are there any types of proof or killer transactions that the team is really focusing on? Say those that are precompile heavy or very memory intensive, ones that are ideal for stress testing these.
Yeah, so the thing that's really interesting is we've got these, the term precompile is like kind of overloaded. In the EVM, a precompile is a piece of highly optimized code that has been artificially reduced in price in terms of the amount of gas you need to spend because it's been so heavily optimized. The interesting thing is when you take that optimized code and you stick it into a ZKVM, the exact opposite is true because despite the fact that it may execute very quickly on a normal computer processor, it executes very slow. So modular exponentiation, ModEXP, different memory access patterns, those are kind of the two that jump out to me. They've got a whole list on the ZKarnage GitHub repo that kind of breaks down the exact number of like cycle multiplier, which is how we determine which one is the most effective in terms of an attack.
Yeah, sounds good. And again, all those kind of results are public, so people can see and identify those bottlenecks, which I think is really great.
Yeah.
And just wanted to ask you also about any kinds of specific results or findings that the team has found with the initial testing.
Yeah.
So any kinds of potential vulnerabilities or any other kinds of, say, like performance bottlenecks that the team has picked up with this initial testing?
Yeah, so we've actually got a paper that we contributed to, coming out next month sometime. It's called Unaligned Incentives, Pricing Attacks on Ethereum Layer 2 rollups. And we've got a whole section there dedicated to proof killers. And basically, the answer is yes. There are some very effective attacks. I can't necessarily say specifically on this particular one because I think this is going to come out a little bit before the paper comes out. But yeah, we've got a whole bunch of them. We've got a whole bunch of them, and they're, I think the paper says 91x in terms of block proving time. So you can take something relatively cheap and you can make it proof for about 8 hours.
Wow, okay.
Yeah.
I see. So be sure anyone in the audience, especially those who are building ZKVMs, to check out that paper when it's going to come out. Yeah, that's going to be very useful. So I know that you are also a proponent for formal verification as well. And a lot of ZKVMs now are also looking into doing some formal verification. So curious to hear from your end why you see it as a very big need for these cryptographic systems.
Yeah, I think that if you're going to secure any, large amount of funds, like it's really important to sort of take all the tools in your toolbox, no matter how difficult or annoying or tedious, and execute them on at like a high level. So I think formal verification is definitely one of those things. I don't really claim to sort of be like a classical cryptographer, so like I can't really comment on like the methods or the means, but I'm really excited that teams are sort of like going through the effort of like auditing their code at a really deep level, make sure that the spirit of it all makes sense.
Yeah, I mean, especially as we're going to more production real world cases like proving these EVM blocks, that's more than necessary. It's imperative in order to make sure that these underlying systems are actually secure. And also wanted to hear more about, I know that while we were speaking about some ideas for this episode, you do have a few different takes. One of them I thought was very interesting was this 200 developer problem.
Yeah.
So why the ecosystem competes for these same number of developers that exist or are currently building with ZK. So can you speak a little bit more about that?
Yeah. I mean, first of all, the reason there's only 2,000 engineers, people, is because this stuff is really hard. You know, like you really got to go like get a very least a bachelor's degree in computer science, if not like some post-grad training, sort of like really fully like understand and contribute to the state of the art. And like even using this stuff is like it's no different. So why are people competing over the same 200 engineers? Is because they just raised 10, 20, 30 million dollars, and it's incumbent upon them, they have fiduciary obligation to compete in an open market. So I don't know, my hot take is that crypto Twitter is a VC echo chamber. So take that as you will.
Yeah, absolutely. And also just thinking, even now that we have easier ways to develop with ZK, there's more tooling, there's ZK VMs, but still the number of developers who are actively building with ZK is still very small. And to think that before, when we didn't have all of this tooling around, we didn't have this infrastructure around, back when we were just writing these circuits by hand, there were even less people who were able to do that. So even though we still have improved developer user experience in ZK, the number of people who are actually using it is still
the funny thing about it is that like that may never change. Is like we're building financial rails here, we're not building necessarily financial front ends. And like I think the users are going to be, you know, 2 or 3, 4, 5, 6, 7 layers of abstraction deep, and like that's where these proofs are going to be, you know. And I think typically in industry, companies don't do hard, tedious, annoying things unless they're made to by regulators. Regulators, you know, compliance frameworks. Once, you know, for example, quantum resistant or just zero knowledge is mandated at some level, like that's the point where it's still going to be 200 people. You know, you have these giant companies hiring like teams of 5 people to implement this on behalf of the entire organization. I don't necessarily think it's going to change.
I see. Yeah. So we'll see coming up, but it's interesting to see that even though we made so many improvements with just the developer experience side, the number of developers hasn't really increased at the same rate.
Yeah.
So we'll see where this goes in the future.
Yeah. You'll have to invite me back next year.
Yeah, and then we can discuss about that again. And I also wanted to discuss with you as well about some of the applications that you see up and coming. Specifically, as you put it, ZK's coming ChatGPT moment, where we can see more mainstream adoption, where we can see more of these ZK-specific applications being built on top of our current infra. And I know specifically that you are seeing privacy for these small and medium businesses to be an opportunity, as opposed to like a lot of cases when ZK, especially ZK infra builders, they're looking at these either big tech companies to integrate with, or just some very big organizations. Even Google, for example, there's a few ZK companies that are looking to integrate with Google Cloud. Google Cloud is also going to have an upcoming ZK and AI conference happening next month. So there seems to be a lot more emphasis on these integrations with these, I guess, these bigger organizations.
Of course.
But wanted to hear about why you see privacy for these small and medium businesses to be an opportunity.
Yeah, like what's interesting is like I actually think that privacy is a secondary application. I think it was Ben Fish was tweeting, Ben Fish from Espresso Systems was tweeting a couple months ago, maybe more than a couple months ago now, about how the prime use case for verifiable computation is situations where you have right around 100 or greater untrusted third parties that are consuming your data. And if you think about enterprise, like giant companies, giant organizations, they might have 100, like literally 100 other giant companies that are consuming their data. And they're very happy with just normal legal contractual obligations in terms of data use, data privacy, you know, things like that. And that's like like privacy is a consumer sort of application. So things that I'm like really excited about are verifiable databases, for example. Like there's like a classic meme in crypto of like, do you really need a blockchain for that? And the answer is no, but you can't get a proof of validity or an inclusion proof from Postgres or MySQL. And the second, like, the people who are making ZK MySQL are going to be the first, you know, $100 billion crypto, organization with like a real legitimate use case. I think the team that is building that, or the closest thing to what I envisioned there, is Space and Time database. They've got a bunch of really cool stuff. They just released their GPU acceleration framework for multiscalar multiplication, and it's very cool.
Yeah, and it's really great to see that we're even seeing improvements on specific operation-heavy tasks like multiscalar multiplication. And I know that there's quite a few ZKVM teams also who are building precompiles against specific very heavy operations. So it's at least good to see that we're making some improvements on more like optimizing specific operations. So it seems to be a big trend right now.
Just on that specific note, like the thing that's funny is like we're still optimizing the guts of the crypto systems, and we're not like necessarily accelerating the specific programs that you're putting on them. Like we're still like 10,000 or 100,000, like times the we're at 100,000 times the native execution speed, and like we need to get to 10,000 or 100x before we start to do like these really meaningful, user-facing optimizations, I think.
Yeah, absolutely. And then even thinking on the end user's experience, they're going to rather natively execute rather than generate a proof if it's going to be that much slower and if it's going to cost them. We've seen this with privacy as well. Like users would sacrifice privacy for convenience. So I think similar to this, if we don't really get to that point where compared to native execution, it's like that much slower, that much cheaper. A lot of times I think users would just prefer to natively execute.
Yeah, and like this is where we get into kind of philosophical, territory of like, my entire life is inside of Google right now, and I can't possibly repeat any of those computations.
Right.
So what am I going to do as a consumer? Just stop using Google? Not really. I don't really have a solution for that, but I think it's an interesting sort of problem that we're going to have to tackle sometime relatively soon.
Yeah, absolutely. And also wanted to hear about your kind of thoughts on what adoption looks like right now. So the way you put it when we were planning for this is we really right now are still selling the vision as opposed to the product. What sort of barriers or challenges do you see that are really preventing us from being able to sell the product, and why are we still at this selling the vision phase? And also curious to hear, since you've been working in ZK for quite some time now, were there any specific challenges that you came across when you first started working in this space, say when you were during your Mina and Cello days, that those specific challenges have been solved now, or any kinds of current challenges we're seeing that you haven't seen before?
I don't know. To speak of the Mina days, the days of 2018 in ZK, that was a time when engineers were basically writing circuits by hand, completely by hand. This is pre-Tornado Cache, like Circom was probably around, but it wasn't even on my radar personally. And Isaac and the cryptography team at Mina were basically writing circuits from scratch in OCaml. And I come from like Python land, that was like really kind of like way over my head at the time. And now the way that ZK VMs are built, like I can understand that architecture. Like that's a von-Neumann machine. Like I learned about that in my undergrad, like pretty much everybody else. And very few teams, if any, have really deviated from that sort of separate computation, execution, memory architecture. And I think that is kind of the most significant thing that has changed, is that like the abstractions are no longer like super low level, and now that they're significantly higher level, we've got compiler tool chains, we've got a tooling ecosystem, but it's still sort of like borrowing stuff from maybe Ethereum or like Rust. I think the reason we've gotten this far is because Rust is really good. It's a really good language, it's a really good tooling ecosystem, and I don't know, if you go try to install any Rust-based ZKVM, you're literally just downloading a fork of the Rust compiler a lot of the time. And I don't know. I think we need probably 5 to 10 more years of like really like hardcore active development until we get to the point of like, okay, normal CS undergrad can like use this transparently, implicitly in like a class, and have it, you know, be a viable thing that they can actually, you know, use into production.
Yeah, absolutely. And I'm just thinking as well, when it comes to, say, building on these ZKVMs, even though we no longer have to, say, use a DSL or write circuits, there's still a learning curve attached because you need to know how to encode the logic of your program. You need to know how to write ZK-specific programs. So there's, I guess, that barrier as well.
Yeah.
In knowing how you can translate the business logic of your use case and encoding that into your program for ZKVM.
Like, a specific like story that I remember was like we were talking about deciding which hashes to use. The cryptography team was talking about which hashes to use inside of the Mina snark. And Isaac, he said something to the nature of like, oh, I heard about this new thing that came out last week, like I'll read about it tonight. And he literally was talking about Poseidon hashing. And the paper had literally just come out, like it was a preprint on Archive the day before, or like the week before. And Isaac went home that night and he came back with a full implementation of OCaml. And like that, I'm pretty sure that is still in the Mina code base today. And that required some like serious background, depth of understanding and knowledge. And like, that is just not the case with the ZKVM. You know, like you really don't need to do that. And I think that is like, I don't know, that's a really nice way to like wrap up that sort of the juxtaposition between those two times of, you know, where we were, where we're at now, kind of wraps it up with a bow.
Mm-hmm. Yeah, definitely. And just on this general topic for more and more of these abstraction layers being built on top, do you still see a need for writing circuits by hand or, say, using ZK-DSLs?
Yeah.
A lot of ZKVMs, a lot of ZKVM teams, they're proponents like, oh, ZKVMs are the end game. We're not really going to need to use to handwrite circuits anymore, but we can see that circuits are still being used in precompiles, and a lot of these ZKVMs are using precompiles to accelerate some specific operations, like, for example, Poseidon-specific hashing precompile. And then there are some overhead that's still present with ZKVMs, like, for example, memory overhead that you wouldn't really see if you were writing a circuit by hand. So just out of curiosity, where do you see circuit-based development and more higher-level abstraction layer, like a ZKVM-based development, interacting in the future? Do you see one kind of dominating over the other, or do you see them being both as essential, depending on the type of use case that one were to build?
Yeah, so, you know, I wrote, like, a lot about sort of, like, how I see AI and ZK sort of, like, mirroring each other in terms of their growth curve. And I think that the ZKVM development sort of cycle growth system is really sort of mirroring the way semiconductor, like CPU manufacturing sort of developed. And, you know, first you make it smaller, then you add more cores, then you add things like speculative execution, all sorts of like different like predictive branching algorithms and stuff to get that extra cycle, you know, out and turn into user land. And I think we're literally doing the same thing. And so like our circuit's important, yes. Like I think the custom precompile development is very similar to like speculative execution, the different sorts of ways that aren't quite software, but they're not quite hardware either. It's like microcode or, you know, maybe a circuit that's like burned directly out of hardware so it's fast. That's what we're talking about here. So if the majority of development is precompiles, we're still in like hardware scaling land. And the funny thing is that I'm very bullish on ZK accelerators. I think the work that Ingo Yama is doing is really cool. They have a partnership with a company called Kornami, which is developing some really cool chips that, I don't know, I think this is a scoop for most of ZK. Like, I think there's like 3 people that I know of that are actually communicating with that Konami company, so go look that up.
Yeah, definitely. And a lot of ZKVM teams are even trying to look into different hardware acceleration options too. Like not just on the GPU side, but potentially with ASICs, with FPGAs.
Exactly, yeah.
And those, from what I hear, are still early on in terms of development, but holds quite a lot of promise. And
yeah, I think it's the only path. It's like it's not just like, oh, it holds a lot of promise, and it's like that is the door that everybody needs to walk through. Is like you're going to need to aggressively optimize your circuits.
Yeah, absolutely. There's always so much optimization that you can do on the software side.
Yeah, exactly.
And even for like a lot of ZKVMs, I know quite a few of them are trying to consider how they can design their ZKVM to be, say, GPU native or hardware accelerated native. Because right now, a lot of ZKVM designs are like built for just CPU native.
Yeah, it's really interesting because these computations are super data intensive. Like if we're talking about the proving of an execution trace, like that execution trace can potentially be absolutely massive. And like talking about continuations, you're splitting that up into little segments that you need to be able to serialize efficiently onto a GPU. And I'm running a boundless prover right now. If you can't tell, I'm like very deep in the weeds of like how to deploy the different sort of agents and how to get the GPUs set up, and we're talking about 8-lane PCIe, we're talking about 16. Like, there's so many like hardware bits and bobs of minutia there to really like sink your teeth into. Which I don't know. It doesn't bode well for the user land of it. It doesn't bode well for the user land of it, but maybe you just get a proof from the proof network, and that's kind of the end of it for most people.
Yeah, definitely. And cool to hear that you're also running your own prover node right now as well.
Yeah.
So you're looking into the security side with Prooflab, and then also running your own prover.
Yeah.
Nice. And just back to Prooflab, in addition to ZKarnage or ZKarnage, are there any other, say, security-related initiatives or stress testing-related initiatives that the team is thinking about building in the future?
Yeah. One of the sort of next big thing I think is going to be in the realm of benchmarking. I'm very bullish on the idea of sort of a unified Rust library that just has all of the really important things to benchmark, all the different types of hashing functions, signatures, etc. That you can just very easily import and use, and like construct it in a way that's uniform and repeatable, and so that teams can kind of pick that up and use it.
Yeah.
Be very excited to collaborate with anybody on that. So if you're listening and you find that interesting, let me know, please.
Yes, please contact Conner about that.
Yeah.
And just as a last question before we wrap up, are there any announcements? I know you mentioned that the report is going to be coming out maybe in the next month or so, be sure to check that out. But are there any other announcements that you'd like to make on behalf of the ZKarnage project or Prooflab? Yeah,
ZKarnage, we haven't started submitting proofs or transactions on mainnet yet because I'm really trying to get some more teams on ETHProofs. So if you are listening to this right now and you have not gotten yourself onboarded to ETHProofs and you're submitting on a regular basis, please do that because we'd love to include you in the project. We've got a paper coming out on August 20th, I believe. Probably end up in the show notes or something there for a link. Got some really cool research and stuff. I think that's kind of it for plugs.
Nice. Very, very exciting time, very busy time as well. But thank you so much, Conner, for joining the podcast. Really enjoyed hearing about both the Prover Killers, the ZKarnage project, and then also your general views of industry benchmarking and even some takes that you have with the overall industry. You've been a veteran of the space, been working in ZK for almost 10 years, so you definitely have a lot of great insights, and thank you for sharing those with us today.
Well, shucks, that's high praise. I appreciate it.
Thank you.
Yeah.